good morning. I apologize for being a few minutes late. I'm not so familiar with the Golden area. Got hit by a train. Well, I got hit by a train. Got stopped by a train. My name is Sean Shore. A little bit about me. I have a background in molecular biology and biotechnology from the University of Hawaii. Did research with farmers there and developed commercial systems that were economically viable. And I have experience in industrial wastewater treatment as well. And right there.
Oh, you're good. As long as Darren is standing there. He's good. There you go.
So aquaponics, it's really just kind of a fancy word that means growing plants with fish food. However, some people got together, had come up with this fancy word. So we take this idea of aquaculture, which is the raising of fish in a either freshwater or saline environment. We do this here in America with catfish. We do this in around the Hawaiian Islands with tuna, and it's really popular in Southeast Asia. And the ponics part comes from hydroponics. And hydroponics is probably a lot more well known, especially with the recent rise in the cannabis industry here. Everybody's growing plants that way. But what we're concerned with really is using this to grow food. So a little basic, breakdown of how it works. So we have a fish tank, we have a pond, we have some kind of reservoir or some kind of container to raise fish. Those fish, they eat food. They, like the rest of us, put excrement into the water, and that water is then pumped from that fish tank to the plants. And we have naturally occurring bacteria in the system that convert the toxic ammonia and the subsequent nitrite, which forms from the conversion of ammonia to nitrite. And they convert that over to nitrate, which is one of the primary nitrogen components that plants can uptake. From there, plants essentially, after they've absorbed all those nutrients, the water is returned back to the system, and we've kind of come up with a water treatment process that's naturally occurring. What's really neat is that there's a lot of applications to this, and this is very practical for you guys. Desktop aquaponics. This happens to be in a kitchen, but this is a small system that's been developed, and it sits right on a normal 10-gallon aquarium. So they've thought of just some of these things from a small system. If you want to get a little bit larger, we have home aquaponics, we can call it. If you want to do this in your backyard, you want to do this in your church, your grandma's backyard, wherever you want, it's available for that. And then we have small farms, scale aquaponics. This is Flourish Farms over in Denver. It's off of I-70 and I-25. And this is about a 3,000 square foot greenhouse that's growing aquaponically. This is a larger scale farm that I helped work on on Oahu. This is about 2-acre hydroponic and aquaponics farm. They have 4 fish tanks that are like 3,000 gallon fish tanks. And they sell mostly to like Costco, Whole Foods, and a lot of people down in Waikiki. So they're doing pretty well. So the core real principle, the thing that I'd like to mainly take away, is that this is about a balance. So we're trying to create an integrated and balanced system that uses the byproducts from one species to let another species grow. So like I said, we're using the byproducts of fish to grow plants. And we're doing this to mimic the natural ecosystem. So why is balance really important? Well, balance, as we're concerned from a food sustainability aspect, is important because our current food system is out of balance. It's like this weird guy here trying to drag a weight on themselves. And some of the challenges that we face with this emerging this emerging industry is looking back at some of the things where we came from, and some of the challenges that aquaculture faces is that we're turning wetlands and mangroves and swamps into aquaculture facilities. We're raising fish in areas that are natural ecosystems and we're destroying them. It's no different than turning rainforests over for corn or for growing cattle or turning our prairie into cornfields. There's a lot of wastewater. These facilities generate a lot of waste and they essentially just dump it right back into the river, right back into the ocean. And so this causes a lot of problems. We see a lot of problems with nitrogen runoff and waste from all kinds of different agricultural products. It goes into the ocean, depletes the oxygen, kills the life surrounding the area here. So this kind of affects how our fisheries, how well they grow, how well they produce, how well they're harvested. If we have all these dead zones in the area, we're not able to fish these fish. And we're not able to grow fish to eat without catching fish because fish eat fish. And what we feed fish is fish. So the byproduct of our major fisheries become that fish meal. So those challenges that they face right there is kind of it's very self-defeating. However, because fish is a lot cheaper to raise than all the other animals, it is increasing. The industry is increasing significantly. So more people on this world, more people wanting meat, more people eating fish. So the other issue is when we look at traditional agriculture, there's a lot, I guess I want to say, intensive use of resources. They're typically, the ways that we water now, they're more efficient than they used to be in the past, but when we're watering things with furrow irrigation, even overhead irrigation, we're very wasteful for the water. A lot of those nutrients that are available in these solutions go right past the plants. They soak through the soil, go down into the water table, go out to the rivers, and pollute the oceans. So this also contributes to the fact that we're trying to grow more food, but we're running out of arable land. We don't have enough land physically to grow enough food for the projected 9 billion people that are going to be here in the next 20 to 30 years. So we're also seeing huge changes in our climate right now. The Earth's going through changes. That's going to affect where you can grow. When you're used to growing in a certain location and now your rains have changed, the sun is different, that really affects how well you can produce food, and you go look elsewhere. And there's limited resources on where that elsewhere really is. So this is really just kind of a breakdown that shows how much energy we're using through all the different types of, the different facets of agriculture, compared to the amount of energy that we actually get from food. So we're getting about 8-9 times less energy than we're producing using the traditional model of agriculture. Nitrogen manufacturing, it requires extreme temperatures and extreme pressures, and it uses a lot of natural gas. We're probably familiar with this, being in this industry where this is part of our life. We're used to this stuff. So we just need to know that it's there. And that 1/8 of our consumption of nitrogen is right here in the United States. We're the world leaders in food production, so it makes sense that we're using a lot of nitrogen fertilizer. I spoke to this a little bit earlier. So this is the Gulf of Mexico, and this is a picture that's kind of showing us what is going on when we release all this fertilizer into the oceans. And we're getting 8 million pounds of nitrogen fertilizer a day to go down the Mississippi. And that's just the Mississippi. That's not all the other river systems that are in major metropolitan areas and major agriculture areas around the world. So this runoff, it promotes algae blooms, These algal blooms use a lot of oxygen, and they suck all the oxygen out of the water, and they kill all these species, all the coral, all the aquatic life, and our oceans become these extremely dead zones. And like I said, it affects how we fish and how we catch our fish. This is illustrating how far it takes from the typical meal. So in transportation miles to go, this is to Chicago, so they just picked a central place. But these foods right here, what I want to point out is they come from all over the world, but we can grow these right now, right here in aquaponics. You guys can do this outside right now. And this is about 16,000 total miles that this food has actually traveled to get to your plate. And then another big issue that we're really concerned about is, again, the carbon emissions that come from this. So this industrialized production of food does impact the amount of carbon, and there's a significant increase in the carbon production when you compare it to local and regional food production, small farms, community farm scales. And as you can see, it says 80% of those emissions happen before that food ever leaves. So you're spending a lot of energy before you even get to eat that food. And when you get to eat that food, you're not getting as many calories. So with all this availability and all these issues, we still face these ideas of these things called food deserts. And the food desert is a place where you just can't get food. They're typically found in urban areas, but they're also in rural areas. These are places where it's not that you can't get food, but that food isn't available to you in a reasonable amount of distance. It's not affordable. All you have is McDonald's and 7-Eleven, and you've got to try to live off Snickers and Big Macs, and that's extremely unhealthy. And these areas tend to be where a lot of the impoverished people and people of lower economic standing tend to live, so they can't afford to go 5-6 miles to go to a King Soopers, to go to a Whole Foods, to go to Costco or even to Walmart sometimes. So it's such a problem that there's an actual map that the USDA has to say, this is how far people have to travel. These are the food deserts. People have to travel a minimum of a mile to get a food. And there's a lot of them here in Colorado. And where Colorado Aquaponics is in Denver's El Rio Swansea neighborhood. And it's off I-70 and I-25 right near the convention center, the National Western Exchange Convention. Is that the name? Anyways. And so Commerce City, if you're not familiar with Commerce City, is industrial. That's all it really is. And you see little bodegas and mercados and little tiny, like a couple fast food places over there. And these people don't have food. So the mission was to go into this neighborhood and try to provide something that was community-based, that provided food, that provided a place for these people to get the food, and provided the community to learn about food. You know, learn how to cook, learn how to do all of these things, learn how to build these types of systems that can do this and empower you to have your own food. So this is the grow house. They have tours every weekend if you're interested in going there and checking out what they're all about. You can get a lot of different mentalities. There's a lot of different, I want to say, backgrounds there, so you get a lot of different angles and perspectives on this topic here. And everybody's really passionate about it. So one of the quotes that we live by and that we like to say is that you can't change things by fighting the existing reality. We can talk about what's wrong and what's this, but you can't really change it by fighting it. What we have to do is we have to create something new that makes the old model obsolete. We have to create something better that makes this. Aquaponics is not going to supplement, or sorry, rather, it's not going to supplant agriculture the way it is to do. We have to use it in conjunction with the current methods that we have. So some of the benefits. Aquaponics uses only 10% of the water that traditional agriculture uses. Because it's a recirculating closed loop system, your water is only lost to the sun and to what the plants use. There's no fertilizers, pesticides, or herbicides per se. The plant, the natural waste product of the fish is technically a fertilizer, but you're not adding any kind of exterior fertilizers to your system. You're not going down to your local hydroponic shop or to your local farm supply and buying these fertilizers and these nutrients. Your only real input of your aquaponic system at that point is the food that your fish eat. That's your main source of where your nitrogen comes from. Soil-borne diseases are significantly reduced. You don't have a lot of cross-contamination. You don't have to worry so much as about salmonella and E. coli because fish don't have salmonella and E. coli. So that's a huge benefit from a food safety aspect. We can kind of look at this raising of fish, and we mentioned tilapia earlier, and can choose species of fish that are appropriate for us that will allow other populations of fish to come back. So we've overfished our ocean significantly in the past couple hundred years, and we've exterminated several species and almost exterminated many other species. So this gives a chance to allow these species come back. It also helps to reduce the amount of mercury contamination that you'll find when you eat these higher predator fish like tuna and shark. One benefit is, like if we do at the grow house, we grow year round. So we can have food all the time. There's a high turnover rate because we're constantly producing nutrients, we're constantly producing plants. The plants that we grow have like about a 6 to 8 week turnover. So you can get a harvest, if you stagger, you can get a harvest every day, every week, every month, depending on your cropping system. What's wonderful is that we've seen that these places are not only great in places that don't have a lot of resources, but that they kind of bring in that local economy and the community to bring in together to try to figure out the problems that occur, the drought issues that may occur. You know, water restrictions are a huge thing that we face here in Colorado, and we're going to be facing them here in the future. So we need to think about this water conservation and resource reduction when we're thinking about some of the benefits of aquaponics. So sustainable food production, we want to do it low, with the lowest footprint that we can do it. So we want to think about doing this as simple, as easy, as small as we can do. This kind of has to be the idea for, think about things that are off-grid, that you can solve problems. You can take this kind of an idea to somebody, somewhere, anywhere, and say, all right, this are the problems. And they go, oh, well, I don't have water. Oh, I don't have electricity. And so you have to think, how can I think of these problems? We have wonderful technologies now. Solar-powered pumps are a tremendous advantage in this industry, where we can go to these remote places and put up really simple things. Integrating this food production idea with other concepts is also key. We're trying to maintain a balance, and the balance comes from a whole slew of things. It's not just one thing. It's just not fish, it's just not plants, it's just not bacteria. There are permaculture, vermicomposting, and those sorts of things out there. Those ideas out there are lend tremendous ideas to the things that you want to accomplish. And I think that the most important thing is that these have to be economically viable. We don't want to make and build systems that are, basically unaffordable. We're trying to solve the problem of food deserts. We're trying to look at affordable and nutritional food. But if you ask the person who's on food stamps, hey, this is going to cost you $3,000, they're going to go to McDonald's every day and buy the dollar, McChicken or whatever. So those are the types of things. You have to make this economically attractive to somebody. One of the challenges that I know I faced with working with farmers was the same thing. They have a couple $1,000s and that's it. And you say, oh, well, I have to learn how to teach you this stuff without using a lot of money, sourcing these materials locally. I can't be in Hawaii and get something from Germany and expect it to be reasonably priced. So we need to think about those things. And when we start looking at that stuff, the local community benefits from that because it drives money into the economy. It creates jobs. So one of the things is, if you guys are going to be building systems, you're going to have these things and you might not be able to keep them. So these are some ideas about, who can produce this food and where you can go to talk to some people. I urge you to go to some of these places. Go to some schools of your siblings if you have any in town, or some friends in younger schools. Schools love this type of system. Aquaponics offers a great educational opportunity for young children. It's a great opportunity for the elderly. I take so many phone calls a day from people that are retirement age that just want to talk to me about aquaponics. And it consumes a lot of my day, and it just made me realize there's a lot of people out there that are doing this, and they don't know anything, and they're doing it. So it's very exciting. So what I would like is we would like to see that these things can be donated, but I think that what's paramount is that you guys go out and reach out to these types of places, and you go say, hey, this is what I'm doing, this is why I'm doing it, and I'd like to know if you're interested. And generating that interest is going to really help drive you to innovate and to learn and to build these things, because you're going to talk to people about the things that they want. You're going to talk to people about the problems that they have. We all think that we can solve certain problems, but when we go into problem-solving situations and we're creating and innovating, we have to find out what it is that the targeted group wants. Who are you doing this for? Why are you making this? And by approaching it that way, you can generate a dialogue, a conversation with these individuals. Maybe it's a pastor who says, oh, this would be really great. I'd love to do this. There's just so many different places. Sometimes I even think about, I would love to be able to just build a little aquaponic system and give it to someone who's panhandling and say, hey, would you like to grow some basil or something? And so, it's silly, but there are those possibilities. These are some examples of some home aquaponic systems. What's great is there's no set way to do this. I guess you guys can pretty much design this however you can see in your mind that's appropriate. Why I meant to bring up that it's important to talk about this stuff is that there's so many opportunities in this industry to learn about things that you never thought you would learn about. I never knew I would learn about economics getting into this. I never thought that I would meet other people that like this stuff, that are more concerned with building things or more concerned with the scientific aspect. These things, it's a great opportunity to learn, and it's a great opportunity to take this out there and meet the people that you're going to be doing this for and try to learn with them. So that's some more pictures from a couple commercial farms, and those are the things that we kind of believe in. So, welcome any questions.
Thank you.
Yeah, thank you.
So, anybody have any questions?
Yeah, I tried doing this system and I had a problem with water, like how to get water that won't kill the fish.
Okay.
I can't get it out of the tap. I tried to do stuff that would precipitate the minerals out, but then I had salt build up. So
We generally recommend that most of the tap water here in Colorado is pretty good. It comes out at a little bit higher of a pH. here, so more of about 8 is when it comes out. Most fish like to live at around 7 to 8. In an aquaponics system, we run our water pH at about 7. So what I would recommend is that you put the water in there, and you get some goldfish. And throw some goldfish in there, and let them just use regular tap water.
The chlorine won't kill them, like I had the,
Go ahead.
well, we had the problem with the fish would suffocate because of the chlorine that was in that water.
How are you setting it up?
I don't know all the details.
No worries. Okay. Well, the main things that fish need are they're going to need oxygen in their water. So you need some kind of an aeration device in there. That aeration will degas the water in a relatively short amount of time. So with tap water here in Colorado, once you start aerating it, chlorine is not really much of an issue. So we don't see much of that as an issue. Yeah.
You said that aquaponics could be applied to an area that is lower income in larger scales, like at the grow house. But if it were to be scaled down to like a smaller consumer base, how does the economics function with maintaining that fish tank so that it doesn't like build up mold, and then they have to pay for the aeration devices, and then like interact or dealing with the disposal of dead fish, or feeding the fish, like maintaining the pH like you mentioned? Like how does all of that work?
So what's nice is that it's very scalable, both economically and systematically. So when you're talking about from a large scale to a small scale, you're going to face a lot of the same challenges. However, those challenges are approached a little bit differently on the small scale versus the large scale. So for instance, on the small scale, we focus on really simple basics of plant care and health care. And we use really simple water quality testing kits that are just droppers that you add into the water that give you a color reading. And those tests are calibrated back to a more standardized test. Usually use like a Lamont test or something. And then as far as some of those problems with like mold and dead fish and stuff like that, that's an issue that you're going to see, I think, in general.
But does that raise the price of maintaining aquaponics system at home?
It
by
doesn't.
significant amount?
No, I mean it's negligible when you compare them to each other. They're not significantly different. So that's kind of why I said the economics are scalable. So if I was going to be doing something small, I would be using smaller aeration, smaller tank, less food, less seed. I would be using a lot less of all of my things. So there would be a lower cost for that. Does that make sense? Yeah. Oh, sorry, I'll get to this.
How difficult and time intensive is it to set up these systems and maintain them, especially for somebody who's elderly or something like that?
So the time that it takes to build them is less than half your day. Most of these systems that we help design, that we've designed, and that there's a large community forum that we have out here, and I can give you guys that address when I'm finished. So the setup is relatively easy. There's a different level of complexity based on what skill level you have. So if you're good with power tools, there's options where you can build your own things. However, if you're not, there's prefabricated type products out there. You can buy molded tanks, molded things like that, so that it's just kind of like a plug and play type thing. So it can become very easy for someone without that skill set. The time is about 10 to 30 minutes a day, depending on the amount of, I guess, time you want to spend. You could spend all day there, really, if you wanted to. But simple 10, 15 minutes a day to feed your fish, to kind of do a little walk around, look at your plants, see what's good. That's a general, typical maintenance type routine. And then anytime that you're gonna be, fixing problems or designing or possibly harvesting on once you start to get larger scales, your time is going to increase. You could probably use those. So some things, if you're using something that maybe I haven't mentioned, just test it out, try it out. See if it's dirty, if goldfish die in it. I mentioned goldfish earlier. They're inexpensive, and unfortunately, they're kind of the canary in the coal mine in aquaponics. So that's our question.
Yeah, how long do the fish last? Like how often will you get new fish?
So from the time that the fish are born, so from the time that they're fry to the time we harvest them is about 18 months. So the fish will live 4, 5, 6 years. They'll get extremely big. I mean, we have catfish that are like this, that are 4 or 5 years old. But typically they get to about plate size in about 18 months. Yeah. Yes?
How do these systems do in an outdoor setting, let's say just in a backyard, as opposed to being indoor?
They do great. We see that it's still relying on the seasons. So especially here in the Midwest and in any temperate climate. So October to February, you're not going to be able to grow as much outside. Precautions that you'll want to take is if you're raising fish. How I said fish take 18 months to harvest. Having some kind of an insulated fish tank or putting fish tanks in sheds or indoors are usually what we see. However, we have a lot of people that just run it like they would run their summer garden and then just eat their fish at the end of the year.
One last question?
Will the fish breed amongst themselves, or do you have to continuously buy new fish?
They will breed in their tank. However, because fish eat fish, if you don't collect the little fry, they just get eaten.
Okay.
Yeah.
Thank you.
Yep.
Appreciate it.